All right, today we're going to jump into one of the most powerful and widespread programming languages on the entire planet, Java. You might not even realize it, but from the phone in your hand to the websites you visit, Java is the thing quietly running in the background of your world.
So here's our game plan. We're going to start with the big picture, the absolutely massive scale of Java. Then we'll zoom right in and decode your very first program. From there, we'll uncover the world-building philosophy at its core, learn its 4 secret rules, and finally, we'll watch a simple blueprint magically spring to life.
Okay, first things first. Before we even think about writing a single line of code, we've got to grasp the sheer scale we're talking about here. Because Java isn't just a language, it's a global phenomenon.
Just look at that number, 3 billion devices. That is just a staggering figure, and it points to one simple truth. This isn't some obscure niche language. This is a global standard that has been shaping the world of technology for decades.
So where are all these billions of devices? Well, you're probably holding one right now. Java is the absolute backbone of Android apps, but it's also running the web applications you use, the software in your desktop, huge web servers, games, and the systems that let us talk to databases. Seriously, it is everywhere.
So what's the secret sauce? Why Java? Well, for developers, the magic is this idea of write once, run anywhere. It just works on pretty much any device. But here's the real kicker, especially for businesses. Java's structure means you can reuse code over and over again. And that doesn't just make programming easier, it saves a ton of time and money. That's why it's been such a powerhouse for so long.
Okay, so we've covered the why. Now let's get our hands a little dirty with the how. We're going to break down the very first thing most programmers ever write in Java, the classic Hello World program.
Yeah, I know. At first glance, this can look like a bunch of intimidating computer speak. You've got curly braces, parentheses, all these weird keywords. But trust me, every single piece has a very specific job, and we're about to crack the code on all of them.
Now, before we go any further, this right here, this is the golden rule for beginners. If your class is named main, your file has to be saved as main.java. Period. They have to match perfectly. If they don't, nothing works. It's like Java's first rule of the club, no exceptions.
So what even is a class? Well, think of public class main as the main house, the container for your entire program. In Java, everything, and I mean every single line of code you write, has to live inside one of these containers.
And if the class is the house, then the main method, that's the front door. Every single Java program has to have this exact line. When you hit run, Java doesn't just start anywhere. It walks right up to this specific front door and begins right here.
And finally, the actual action. What does our program do? This command, system.out.println, looks kind of long, I get it, but its job is super simple. Whatever you put inside those parentheses, it just prints it to the screen. That's it. In this case, it prints Hello World.
So we've seen the basic words and punctuation, the grammar, right? But the real genius of Java isn't just about the syntax. It's about this huge idea, this whole philosophy that totally changed the game for how we build software.
And that big idea is called Object-Oriented Programming, or OOP for short. The concept is actually pretty intuitive. Instead of just writing a long list of instructions, you create digital objects that act like things from the real world. You know, like a car object that has a color and a speed, or a person object that has a name and an age.
And this whole OOP thing? It's all built on 4 key principles. You can think of them as the pillars holding everything up. Once you get these, you really get how modern software is put together.
First up, encapsulation. This is all about security, really. It's about bundling an object's data and the code that controls that data together in one safe little package. The bank account is the perfect example. You can't just reach in and change your balance, right? You have to use the official deposit or withdraw functions. Encapsulation keeps everything predictable and safe. Next, we have abstraction. This is all about keeping things simple. When you drive a car, you just use the steering wheel and pedals. You don't need to be a mechanic and understand exactly how the engine works. Abstraction does the same thing in code. It hides all the messy, complex details and just gives you a simple way to get the job done. Our third pillar is inheritance, and this one is a huge time saver. It's all about code reuse. You can start with a general animal class that knows how to eat and sleep. Then you can create more specific classes like dog and cat that automatically inherit all those basic animal things. You only have to code what's unique, like bark or meow.
And our last pillar is polymorphism. Don't let the fancy word scare you. It just means many forms, and it's all about flexibility. Imagine you have a single command, draw. If you tell a circle object to draw, you get a circle. If you tell a square object to draw, you get a square. One command, many different results. That's what makes code so dynamic.
Okay, that was a lot of theory, I know. But what does this stuff actually look like when you're coding? Let's connect all these big ideas to a real example and see how a simple blueprint can come to life right before our eyes.
So, this is probably the most important concept to nail down, the difference between a class and an object. A class, that's the blueprint. It's the design for a car on paper. An object, that's the actual car, built from the blueprint, ready to drive. From one single blueprint, you can build millions of unique cars. And here's what that blueprint looks like in code. See this car class? It's just a template. All it says is that any car we ever make is going to have two properties, a color and a speed. That's it. It's just the plan, nothing more.
And this is where it all comes together. Using our car blueprint, we're now creating two totally separate real objects. We make car 1, it's red, and its speed is 120. Then we make car 2, it's blue, and its speed is 150. See that? Two different objects, each with its own unique data, but both built from the exact same plan. That's the essence of OOP right there.
So there you have it. We've seen how Java uses these ideas of classes and objects to literally model our world in code. It's this incredible way of thinking that takes huge, complex problems and breaks them down into simple, manageable parts. Which kind of leaves me with one final question for you. If you were going to design a blueprint for any object in your life, what would be the first one you'd build?